In this video, I'm going to take some parabola graphs and turn them into equations. And then a little bit later on, I'm going to take some characteristics and write equations based off of those. So let's jump right into problem number 5 here. We have a parabola that is right facing. So when it says it opens, I am going to put it opens to the right, but I'm also going to remind myself that if it's a right facing parabola, that means it's going to be y squared, and it's also going to be positive. So where's our vertex? Let's find it. Let's see here. That looks like 2, 1, 2, negative 2. All right, so 2, negative 2, and we have a focal distance of 2. So using that information, I can basically reverse what we were doing in the last video of making the equation turn into a graph. So let's see here. We're going to have y squared. I know this is going to be negative. Nope, it's going to be positive. I lied. It helps if I actually look at what I wrote down. All right, and it's going to be x. All right, so let's take apart the vertex here. We know that what's attached to x is supposed to be a negative 2. What's attached to y is going to be a positive 2. And I'm going to take that focal distance and I'm going to multiply it times 4. And so that's going to get me an 8 there. And there's nothing in this problem that says you have to multiply it out. So I would just leave it as is. Maybe the only thing I would clean up is I don't need the positive in front of the 8. We know that it's there. So I'd probably take that out. But that's how you can translate a given parabola into an equation. Let's do the same thing for problem number 6 here. All right. Problem number 6. Let's see. It opens down. All right. If this graph opens down, this is going to be x squared and negative. Our vertex here is 0, positive 5 with a focal distance of 1, 2, 3. All right. So using that information, I can translate it into an equation. So we're going to have x squared is equal to negative, right? And we'll fill this in for a minute. And then y. All right. So let's translate that vertex. Attached to x, we're going to put either a plus or a minus 0. It won't matter because we'll fix that in a second. Minus 5 gets attached to y. I'm going to take my focal distance, multiply it times 4. Now, this one I am going to clean up just a little bit. I'm not a huge fan of leaving x plus 0 squared. It seems relatively redundant. So I'm just going to put down x squared is equal to negative 12 times y minus 5. Again, nothing in this problem says you have to multiply it out, so let's go ahead and leave it in. These are all in standard form for us. All right, last one for the graphs. All right. We're given a graph here. In this case, this is opening up, which means it's going to be x squared and positive. Our vertex here is negative 2, negative 5. Focal distance 1, 2, 3, 4. So let's go ahead and translate that into an equation. I'm going to have x squared is equal to something and then y. So let's go ahead and pull apart that vertex. So positive 2 with x, positive 5 with y. So plus 2 plus 5. Take your focal distance of 4, multiply it times 4. So it's going to be 16. And that is absolutely fine. All right. I suppose I could get rid of the line underneath the 16. It's unneeded, but it's fine. All right. So that's how you can take an equation or create an equation from a graph. Now, for the next 3 problems, I've given you certain characteristics, and I'm asking you to write an equation. I am asking for the equation to be in standard form. That's what we've been writing for these. And we're also going to multiply it out to get general form. All right. So the biggest thing I can tell you with these is to understand what I'm actually giving you and draw yourself a sketch. All right. That's going to be the biggest thing. No, I'm not looking for perfection on this sketch. I don't think you should either, but at least get the idea of where these points are or where the directrix is so that you understand how the graph is opening. All right, so in this case, I've given you the vertex and a focus. So let's go ahead and graph that. All right, so my vertex is -3, +2. So I'm going to go ahead and mark the x-axis -3. There's a +2. Okay, and I have a focal point of 2, 2. So that would be over here somewhere, and that's a 2 right there. So this information tells me that I have a right opening parabola. So when you look at your parabolas, the parabola always curves around the focal point. And so that's why I know now if this is how my vertex looks and this is where my focus is, I have to have a right-facing parabola. So that means this is going to be opening to the right. If it opens to the right, it's y squared and positive. All right, focal distance. So what I want to look at is how far apart are the vertex and focal point from each other. And that's going to be 3 units here, 2 units, a total of 5. So my p-value here is 5. That's my focal distance. Okay. And so if I use this information, I would have, let's see, y squared is equal to, let's see, x something. So I know my vertex because that was just given to me. So let's attach x to x and y to y. So +3 - 2. Take your focal distance, multiply it out by 4, right? It's always multiplied by 4. So that's going to be 20. So what we've just written here is the standard form. All right. So y - 2 quantity squared is equal to 20 x + 3. All right. Standard form, great, fabulous, done. Now, general form, it just takes this standard form and multiplies it out. All right, so y - 2 squared is y squared minus 4y + 4. And I'm going to distribute the 20 on the other side, so 20x + 60. All right. And then basically what I want to do is collect everything to the left side and make it equal to 0. That's what general form is going to be. So y squared minus 20x minus 4y minus 56 equals 0. All right, so you start with your squared. You've got your single xy term, your constant, equal to 0. And that's general form. So y squared minus 20x minus 4y minus 56 equals 0. Okay? All right, so that's problem number 8 there, right? Given a vertex and a focus. Let's see in problem number 9, we're given a vertex and a directrix. Okay, again, I always want to start these with a graph. I need to visualize what's going on here. So my vertex is the point 2, 0. All right, so that's going to be 2, 0. And my directrix is y is equal to 4. Well, directrix, let's see, y is equal to 4 is going to be up here. So what does this tell me? Well, it tells me that this is going to be a concave down parabola. That's what it tells me. I know that my focus is always the opposite direction to the directrix. So my focus is down here. The other thing I know is that your parabola can never touch the directrix. It just can't happen. So there's no way for this to be concave up, concave right, or left, because all of those would touch the directrix. So it has to be concave down. So we've got the vertex. Focal distance here, well, how far is it from the x-axis to y is equal to 4? Well, it's 4 units. All right. So again, that all helps me count it out when I can see it in the picture. So this is going to be opening down. So this is going to be an x squared with a negative. All right. So let's go ahead and attach the vertex to the x and the y. So -2, again, plus or minus won't matter. It actually, you don't have to put anything with y because I would clean that out anyway. My focal distance is 4, so I'm going to multiply that times 4, and that's going to be 16. So my standard form equation here would be x minus 2 squared is equal to -16y. All right. Now, if I take that standard form equation, it's fabulous as it is in standard form, but I asked for general form as well, so multiply it out. So x squared minus 4x plus 4 is equal to negative 16y. Go ahead and pull everything to the left side and make it equal to 0. So x squared minus 4x plus 16y plus 4 is equal to 0. So there's my general form. Let me make sure I can actually see it as I write it over on the little line here. X squared minus 4x plus 16y plus 4 equals 0. General form.